Hello everyone. Thank you for joining us. I am Shubhrato Sarkar. I am the coordinator of NANO Global Project. And today we have Dr. Sophie Siava, the CEO of POGO, and Dr. Lillian Krug. She is the scientific coordinator of POGO. So I welcome you all to the NANO webinar series. Those who are not aware about the NANO is NF POGO Alumni Network for the Ocean. So this is a network of current and former scholars who received training from the POGO. And our mentors are also the member of this network. And the objective of this network is to maximize the benefits that scholars received from the training, as well as to extend the opportunities beyond these different trainings. We have different activities. For example, we do networking, we have joint research projects, and we have outreach and capacity building activities. And this NANO is one of our research projects. So NANO is a global study of deoxygenation, ocean acidification, and productivity at selected sites. The primary objective of this project is to support in situ monitoring of essential oceanographic variables from some selected sites from Asia, Latin America, and Africa. Currently, we have about 36 sampling sites from 18 different countries, and we basically measure essential oceanographic variables, for example, temperature, salinity, dissolved oxygen, chlorophyll, and pH. But some sampling sites also measure different other variables like phytoplankton and some other oceanographic variables. In addition to measurement of these oceanographic variables, we also have the capacity build development activities, and we also have the outreach and citizen science activities. And we have some data from our sampling sites. Now we are doing interstation comparison of data, and this webinar is part of our capacity development activities. So in this webinar, we invite one speaker to share their recent research activities with us so that it can enhance our understanding about the recent research in oceanography. So today we have Dr. Kwame Agyekum from University of Ghana with us, and he will talk about supporting fisheries management using Earth observation data. Dr. Kwame Agyekum is a faculty member at the University of Ghana and the project coordinator for the GMES and Africa Marine and Coastal Area Management Project for North and West Africa project. Dr. Agyekum has been interested in using marine Earth observation data for fisheries management as well as in maritime security and safety. His work at the University of Ghana largely focuses on developing coastal and marine services to support monitoring, control, and surveillance activities of coastal states in West Africa. His research aims curbing IUU fishing by using various in situ, modeled, and space-borne information such as fishing vessel traffic information, satellite remote sensing data, and forecast products from Mercator Ocean to develop potential fishing zone maps and support fisheries management activities. Thank you, Kwame, for accepting our invitation. And before we go to Kwame, I want to mention two important issues. First one is this webinar has two segments. In first segment, we'll have 30 minutes talk from our speaker, and then we'll have a question and answer session. So if you have any question, you can raise your hand or you can just write your question in the chat box. And the second issue is we record this webinar and then we upload this webinar in the POGO YouTube channel later. So if you do not want to be recorded, please switch off your camera. Thank you. And over to you, Kwame.
All right. Thank you, Sibrata, for having me. I hope you can all hear me.
Yeah.
We can. Thank you.
Okay, good. All right. Then let me go ahead and I need to share my screen. So Subrata, if you can take off your screen, then I can share mine. All right. Can you all see my screen?
Yes, perfect.
Yes. Yes. Hello, everyone, and it's good to be here. I mean, POGO has been doing a lot for many people in developing countries, so it's a good thing to build on this network and to look at the various activities POGO is engaged in. For us at the University of Ghana, we are a partner. Though I haven't been part of any of the POGO activities, I have keen interest in what POGO does. So for us, it's a good opportunity to showcase what we do. I am the project coordinator for the MarCNoWA project. It's part of a Pan-African AU-funded project that supports countries in the region to utilize EU data, build capacity, engage people, so that we improve the uptake of EU data and in situ measurements in natural resource management. I am based at the University of Ghana, and I lead this project. So there are 18 countries involved in this project, 6 in North Africa and 12 in West Africa. There are about 10 partners, and this consortium is led by University of Ghana. The institutions that we work with include the Center for Oceanographic Research in Senegal. There is also CURAT, based in Cote d'Ivoire. There's Ghana Meteorological Agency. There is Nigeria Institute of Oceanography and Marine Research. In Benin, we have the Institute of Research. My French is a bit bad. The acronym is EROP. There is UCD in Morocco, SET in Tunisia. We have Center for Environment and Development for the Arab region and Europe, based in Egypt. We have Nature Today in Ghana, and recently we added another partner based in Ghana called Eden Way Foundation. So these entities support the University of Ghana to develop various services, come up with training materials, develop strategies for engaging policymakers, and carry out outreach activities. So at the end of the day, we want to ensure that we engage entities within the two regions, that is North and West Africa, to overcome the various challenges we have in the fisheries and coastal area sectors. You all know what the challenges are. I'm not going to go so much into details on that. There are a lot of environmental impact challenges that we face. You all know about climate change and its effect on fish distribution, its socioeconomic implications. There are issues related to maritime security, fish and food security. In the Gulf of Guinea region, piracy is huge. IUU fishing is also a bane in the region. Day in, day out, you have a lot of vessels moving into the maritime space, taking fishes that they are not legally allowed to do. There are issues related to poor governance and management policies. There is pollution and there is overfishing. So for us, it's imperative that we come up with strategies that would allow us to have a clear view of what happens within ocean space. We also need to understand the ecological processes that drive fish distribution, and satellite data provides all of this. I mean, looking at the vast ocean, it's important we take advantage of what remote sensing provides. So the GMES in Africa project generally aims at providing information and tools that will help entities within the region to effectively manage their marine and coastal resources. Ideally, we want to ensure that there is enough information available for institutions, universities, research centers in the region, so that they can effectively exploit EU-based services. Again, we also carry out these activities to support the African space policy and strategy that we have funding for. The funding that we receive from for this project is sort of an offshoot of that broader African space strategy and program. And at the end of the day, all of this must feed into what the countries carry out in terms of resource management. Decision makers who may not be very technical should have some idea about the relevance of Earth observation, and in building policies, Earth observation should become an integral part of a support system that would allow better management of resources. So that is the primary purpose of this project. So why are we so keen about having better governance strategies, better policies that can support our maritime space and the resources being there? We are doing this largely to harmonize institutional structures. I mean, you realize that there are different countries, there are different expertise, there are different interests, there are different focuses. How do we come together to get people to talk, get people to know the benefits of EO, so that there could be a concerted effort at building solutions? Because fish and marine living resources do not have boundaries. So strategies in ensuring that they are sustainably managed should be harmonized, should be uniform, so that we can make better gains. So in also doing all of this, we also aim at improving the benefits that we can get from our blue economy. The ocean space has become an important area for transportation, for shipping. There are a lot of facilities dotted around the coastal areas, and the benefits we get from them, we have to sustain that. We also need to conserve the very important ecosystems that sort of drive or sort of affect or determine how sustainable our fish assemblages would be. So at the end of the day, countries within the region must have a strategy. And one of our main pillars looks at that. How do we bring together policymakers? How do we show them the importance of EO in resource management? So there are various activities that we carry out, and I'll be showing some of them in the slides as I present. Again, we all know the constraints with internet within many developing countries. Yes, that is one of the challenges that most entities face in here. So we also have to come up with strategies for making data as accessible to our beneficiaries. We largely utilize the UMETcast station. That is not to say that it's the only means of making data available to our beneficiaries. In some cases, there are good internet connections. So those institutions, they use the various portals under the Copernicus program, where they access EO data from optical, thermal, microwave, and so forth for various applications. So this is an example of the UMETcast station. It's a dish connected to about 3 PCs that are for data reception, ingesting, processing, and visualization. It's operated by UMETSAT, and it's also the software for running that setup is developed by JRC. Again, we also develop we have a geoportal where we can access data. So apart from sometimes putting data on hard drives that we make available to our partners and institutions within the beneficiary countries, we also put some of these data sets that we have already processed on a geoportal for easy access. So what are some of the EO services that we develop? There are about 6 services that we develop, basically looking at fish distribution, vessel traffic, pollution, and coastal ecosystem monitoring. So yes, these are the services. The first is, how do we make our users have access to simple plots of 2D plots or time series plots of some essential oceanographic variables. We have tools for doing that. There's also a service that looks at fisheries resource management, basically generating potential fishing zone maps combined with vessel traffic data for a better understanding of the dynamics of fish distribution and the human impact from fishing vessels. There's a coastal vulnerability mapping service. We have a safety at sea service where we target artisanal fishermen and make available to them periodic information on the state of the ocean to ensure that they only step out to go to sea when it's safe. Then there are vegetation mapping services. We focus on wetlands. Then there's also an oil spill monitoring service that we are developing. So these are the services. We currently are working on having a dashboard. In the past, we used to produce periodic bulletins that we would make available to interested entities who sign up for that service. So we periodically send out emails with PDFs of these bulletins attached, but we want to move away from that. You would reach a wider audience if you use web tools like dashboards. So that is something we are working on now. Various data sets are used for this. We widely rely on Copernicus products. We sometimes also use some of the NOAA products in generating this service. Then we also have a fish mapping service. We basically map areas of the ocean where we think the conditions are right for fishes to aggregate. Most people have always felt that we make this service available to fishermen. For us, it's vice versa. We rather make it available to people involved in monitoring, control, and surveillance, because in West Africa, not in North Africa anyway, in West Africa, there is excessive fishing. The region is overcapacitated. Lots of artisanal fishing vessels. In Ghana alone, we have more than 10,000 canoes. There are other semi-industrial and industrial boats. There are weaker surveillance systems. So we try not to provide information that will lead to overfishing. So this model we run from the University of Ghana basically utilize vessel traffic information. Ideally, you would want to develop this sort of service with logbooks, data information on where fishermen had caught fish from logbooks. But when we started working on this service, we realized that the logbooks were not properly completed. There were a lot of gaps. There were a lot of inaccurate location reported in those logbooks. So you'd take a lat long, you plot it and it falls on land. So we felt it wasn't the right tool we could, the right source of information we could rely on. But thinking through, we realized we could generate fishing grounds maps from AIS data, because fishing vessels do basically three things. They are port waiting to go to sea, they speed to a fishing ground, and at a fishing ground, they slow down. They don't have a proper orientation their movements are sort of determined by the movement of the current. So when you understand these things, you can understand or tease out their behavior from AIS data. So from AIS data, we are able to generate fishing spots, which we can superimpose on EO data from either satellite or model products. Then we will then extract the conditions, the ocean surface conditions that were present when fishing was carried out. We can put all of this into a model and come up with tools that would allow us to predict these fishing grounds. So in the next slides, you can see an output of the model. It's it's on the the color map next to it. It starts from 0 to 1, where you can see where you have 0, it suggests the conditions are not so perfect for fishes to aggregate, and where you have 1, it means it has perfect conditions. The interesting thing is that you can see a lot of oceanographic features associated with perfect conditions for fishes. You can see eddies, meanders, fronts. So these sort of information provides are sort of good proxies for fisheries managers to look at, so that in case they, assuming they won't even plan any monitoring campaign, they don't have to go wandering. They can target certain places to go and hope that they could monitor the activities of fishing vessels, especially the industrial ones that engage in fishing. Again, we can also analyze the AIS data for various applications. I mean, from monitoring legal fishing, developing trip metrics for monitoring or managing fishing efforts. So these are add-on services that we hope to add to our existing services under this portfolio. Then we can also analyze AI's data to detect transshipment, close season area monitoring. I'm going to show slides on that, and so forth. I mean, at some point, I remember we even provided some targeted monitoring for Liberia, where they had indicated to us a particular vessel that they think had moved into their water without license. And yes, we went out, analyzed AIS data over time, and we were able to give them a very comprehensive report on the behavior of that fishing vessel. This is an example we did for Ghana, I think 2 years back, on closed area or closed season monitoring. At the end of the day, we were able to show to our policymakers that sometimes these directives for closed seasons are not properly respected. It provides them insights on strategies to use for proper implementation of those directives. This slide also shows how we have come up with strategies to monitor industrial, semi-industrial boats and artisanal canoes. You would know that apart from legally, industrial boats are the only ones that have to be monitored electronically. The semi-industrial and artisanal boats can step out anytime and operate. But we don't think that is prudent and sustainably a good thing to do. So we look into putting transponders. These are Class B transponders that we put on these boats. You can see one of the alumnus from Pogo, Mr. Benetachu, installing the device. We moved away from using batteries to even use solar panels to look at these vessels, look at the behavior, to monitor the behavior of these small vessels, and it worked out perfectly. I mean, what you only have to do is ensure that it's properly positioned, it has a clear sky view, and that is it. It can be picked up by satellite and it's powered enough, and you are good to go. We looked at data from, I don't have the slide here, but there was enough data. We collected very good data that allowed us to look at the behavior of the small fishing vessels, how far they travel, the duration of fishing, how long it takes them to get to fishing grounds, and so forth. So I think at some point, Gambia looked at carrying out monitoring of small canoes with this technology. We also look at shoreline monitoring. There are a lot of assets located within the coastal area, so it's important to know how fast your coast may be eroding. In West Africa, coastal erosion is a huge problem. So it's important we look at that. So we work by looking at the shoreline, the watermark from satellite data. Currently, sometimes it's difficult using optical data to look at shoreline or use optical data in tropical areas. So sometimes we also rely on radar imageries where we tease out the shoreline. Then we have a transect drawn across these shorelines. Then we're able to calculate the rate of erosion for various periods from the shorelines. This has allowed us to know which areas of our coast are very, very susceptible to erosion. This is a key component of our CVI service. It allows us to identify risk areas, provide information to coastal managers on how fast certain parts of the coast is eroding. There's also the coastal ecosystem mapping and monitoring service, basically using optical data to tease out the various major vegetations within parts of our coastal regions. This allows us to look at land cover changes, so we are able to tell which parts of the various wetlands, especially, are being impacted on by humans. Sometimes people cut them for firewood or they are cleared for settlements, and it's important we provide that information to the right government agencies to help them know how things are changing. Then we have this our flagship service, the Safety at Sea service. I mean, it started as well, how do I put it? It started as a very simple service where we were using flags. Then we realized that we could reach out to more people by building a USSD service. So we got an IT expert to develop this USSD service that allow us to send text on the state of the ocean to fishermen and coastal communities. So you realize that we have various colors here. Green, next to it is 1. Yellow, next to it is 2. Yellow signifying that it's rough. Green is a bit calm, so you can go to sea. Then red is very dangerous. Please don't step out. So we send out this information to coastal communities involved in this project daily. It's 3-day forecast, so they know ahead of time when it's safe to go to sea. We've also upscaled this a bit with an app that allows people with Android or smartphones to use the service. And we realized we could also blend all of this with the flag. So the point is that not everyone would have a phone, and this allowed us to reach out to a larger audience in the sense that we identified only an opinion leader in a coastal community. He receives the text and he goes to hoist a flag near a fishing or landing site. Then it sort of tells the fishermen around whether it's safe to step out to sea. So this is the service. You can see how we disseminate the service to our beneficiary entities. There is also a lot of oil spill incidents within our region. The Gulf of Guinea has a lot of oil exploration or exploitation platforms. So it's important to have strategies to look at how vessel activities that commute within the region and the exploration of oil is impacting on the environment. So in North Africa, this service is already operational, but in West Africa, it is not. So basically, we rely on radar imageries that we process to identify oil slicks. When radar pulses from satellite hits the ocean surface, because the ocean is rough, quite a number of the return signal or the backscatter goes back to the sensor. So because signal goes back to the sensor, those pixels are brighter compared to areas that have slicks, because when the pulses hit the surface, it's smooth because oil will dampen Bragg waves. So the signal is reflected away from the sensor, and that part of the image looks darker. So you can process this to identify areas of the ocean that may have oil slicks if they are present, and there's a satellite image covering that image. There are a lot of processes involved. I'm not going to go into that, from land masking, adaptive thresholding, and some morphological operation to know the size of the slick, the location of the slick, and so forth. We use various data sets from Copernicus. We rely largely on Sentinel-1. There is also wind data for building a dissipation model that we want to include in this service, so that we are able to know where the oil slick would go within some space of time. There's also an opportunity to use the radar images for ship detection. You know, we already have AIS data, so it becomes a bit easier to even validate the ships and to even know vessels that are not reporting their position. This is very useful for maritime domain awareness. We are working hard to engage the private sector, because the idea is, over time, we need to transfer these sort of interest and expertise to people who are supposed to be in that business. So the way the project is designed is we are encouraged to engage the private sector, so that we sometimes guide them on how to develop EO services, or some of them are already skilled enough to develop EO services or support us in diverse ways. So when they come in, it helps in a better service development and service delivery. Then we are also involved in capacity building. There are various training programs that we offer. It could be online, hybrid, face-to-face, on remote sensing, programming, training on remote sensing and GIS softwares. Because at the end of all of this, we want to ensure that we have contributed in improving a critical mass of African experts who are able to utilize satellite data. So that is one of our primary focus. We are also involved in helping people develop EO services. So you may have an idea, you engage us, we guide you through it, and where we have enough resources to support you, we step in to do that for you. We also engage policymakers, fisheries managers on the importance of EO applications. It's very, very key in terms of policy guidance and directing how policy should be going forward. So these are some of the pictures we have in terms of engaging the academia and so forth. There are various training activities we have carried out over the years. So this project has been around since 2013. It's the focus has always been very, very, very similar, but it's only the name that has changed over time. So we are this is our third funding period that we have received from the EU and the African Union. So these are some of the outreach activities that we also engage in: cleanups, end user engagement, education on EO. Even sometimes we step out to work with people on IoT, Internet of Things, how to build low-cost sensors for in-situ data collection and so forth. Okay, so we also utilize a lot of social media tools, because at the end of the day, we want people to know about what we do. So we utilize WhatsApp a lot to communicate our service. We are on Facebook, Twitter, and so forth. So you can always check on us and see what we are doing. So this would be the end of my presentation. These are social media handles, and please feel free to get in touch with us. All right, thank you so much.
Thank you, Kwame, for your interesting talk. So now we will have a question and answer session. So if anyone have any question, you can press the hand raise reaction, or you can just write your question in our chat box. Yeah, Paul.
Yeah. Can you hear me?
Yes, I can, Paul.
Yeah. Kwame, thank you so much for your presentation. That's very educative. I'm Paul from Fisheries Commission. Okay. I'm a fisheries speaker, yeah. I'm more interested in the capacity building, you know, because I've been in the Fisheries Commission for some years now, and I quite remember 3 years ago we had a meeting with you guys at Jamestown Landing Beach, you know. Yes. So I guess my jurisdiction is from Jamestown to Choco area, that Landing Beach. So I've seen that flag thing, the red flag, when the sea is coming. I've seen it, and you are doing a lot of good job. But you know, I'm interested in the capacity building and how to get myself involved, and especially the one you talk about, the EU applications. Like, if someone like me, I want to acquire knowledge on that area, what's the procedure? Am I going to apply? Am I going to see you in the University of Ghana? I don't know the procedure. So I'm more interested in that application, because I'm also part of the policy makers, you know. And if I get extensive knowledge on that, it will help me in my career, you know. So if there are links or you have a schedule that you have been doing that program, I'll be very happy to be part of that program. Yeah.
Okay, can I go ahead and answer?
Yeah.
Yes. Or yes. Oh, yes. So Paul, thanks for knowing what we do, and we'll be more than happy to help you in any area that you might need assistance on. You can always know about our upcoming training programs from our website or our social media handles. I am in constant touch with your colleagues at Fisheries Commission and MCS. So coming up with training programs for you wouldn't be a problem at all. I mean, there's been a lot of instances where they've been your colleagues have requested for training, especially on AIS, VMS data analysis, and we have always been up to task. So you can always reach me. Perhaps I will find a way to find you easily, because I know how to. Yes, so I can give you a call. Then we start talking on. Just let me know anything you want to do. I would be more than happy to help you with. If I can't do it personally, I've got colleagues who can help you with that. Yes.
Okay. Thank you so much.
You're welcome. Yeah.
Thank you, Paul, and thank you, Kwame. Any other questions? Lika?
Kwame, thank you so much for this great talk. I'm really impressed with all the activities. I was wondering if there is, like, it's 10 years already of the program, right? And if you've seen an improvement on recognition of the importance of Earth observations among policymakers, and what would be the most difficult part of, you know, convincing government, local government, or financial funding agencies on the importance of maintaining a sustainable Earth observation system in the region.
Okay, good. Thanks. So over the years, we've seen improvement in the uptick on EU services. It's been slow, largely because I feel there is a huge gap on the expertise required to utilize EU in some of these institutions. For instance, it's taken me decades to become good at what I do in analyzing AIS data and so forth. So stepping in briefly to give them training does not solve all the problems instantly. It takes a while. So for us, currently we largely focus on training the youth in people like Paul, training people, younger officers, so that over time they grow to understand the relevance and build skills in using EU. So that slowly these institutions can take up EU services, EU tools, EU technology in solving the problems that they have. It hasn't been easy working with these public entities. largely because one, sometimes they also don't have the resources. I mean, I would come in and suggest EU tools and services, but if you don't have within your workspace an expert who can program a bit, or who is ready to use a particular Earth observation software, then there's a slight bottleneck in that respect. Again, sometimes they also need some infrastructure to be able to set themselves up to be operational. That's the right thing to say. But it's a bit, sometimes they do not have these resources to be able to do that. So these are some of the challenges. But all in all, I think things are getting better, because now a lot of people know about Earth observation. For me, it's a good thing. Knowing about it is good enough. Knowing the benefits, it's good enough, because slowly you would realize that the example I gave about Gambia was ready to spend some money to buy Class B transponders to track small vessels. I know Ghana at some point bought quite a number of Class B transponders to monitor those small fishing vessels. Some countries have also gotten to us to build, to develop targeted training on specific areas for them. So the point I want to make is that we are slowly getting somewhere. I mean, it's way better 10 years back.
Okay, thank you. So we still have time to take few more questions. So if you have any questions, please. Okay, Kwame, I have two questions. So you are using chlorophyll data to identify the PFZ. So do you perform any validation before you use the chlorophyll data directly from the satellite? Because if we think about the Bangladesh coast is very turbid, and we can see very large variation between in situ chlorophyll and satellite-based chlorophyll data. So do you do any validation for the satellite chlorophyll data before you use that as input variable for PFZ?
Okay, your second question? Oh, it's just this.
And the second question is, okay, so you are giving information about PFZ to fishermen. So in that case, do you also monitor their catch? Otherwise, there will be a chance that fisherman is going to overfish from the system if they have the information.
All right, thank you. So our PFZ maps do not go to fishermen. We rather make it available to people involved in monitoring, control, and surveillance. So for instance, the Navy, the Coast Guards, and so forth. The whole idea is know where it's likely fishing vessels would go and keep an eye on them so that they do not overfish. So that is the main focus of that service. Then with regards to chlorophyll A is the use of chlorophyll A in our model it's less weighted in the sense that we do not, we live in a tropical region, and most of the images we get often have cloud cover, right? So we don't rely so much on that. SST is one of the key components input for the model, and other processes like currents, the speed of currents, the direction, and so forth, salinity. So these are the inputs into the model. But where if you are in a region where you have very good chlorophyll A measurements from satellites, then it would even make your model better. So currently we don't use much of it. I mean, when we have a good image, we use it, but when we don't rely on that.
So what is the contribution of SST in the model? I mean, how much variability is explained by SST?
It runs between 60 to about 65%. It contributes significantly. I mean, for instance, the Gulf of Guinea region is upwelling driven. So obviously measurements from SST is essential for this. One of the things we have also thought about is overlaying these PFZ maps with frontal maps. Currently, we are not doing that. But we want to develop frontal maps from SST, satellite measurements, to see how it can help improve this. So these are some additional ideas that we have thought about including in the service to make it better.
Okay, thank you. So next question will be from Mohammad Mizanur Rahman.
So thank you, thank you, Kwame. I'm Mohammad Mizanur Rahman from the Department of Oceanography, Shahzara University of Science and Technology, Bangladesh. Actually, this is from my understanding. Kwame, we have shown in your slide for coastal erosion measurement, you have used historical orthophotos. Actually, I want to know how did you use this historical orthophotos for coastal erosion measurement?
Okay, so apart from the orthophotos, we use satellite data. But this is how you would use the orthophotos. You get a very, like, there are different orthophotos for different years. You digitize them, then you draw, you get the outline of the coastline. It would come with its lats and long, and it's properly georeferenced and so forth. Then it becomes an additional input for estimating the shoreline rates. So basically, get it digitized, and that's it. You can extract the shoreline from that.
Okay, thank you. Thank you.
Sure.
Okay, thank you. Still, we have 10 minutes. So if you have more questions, we can take.
I just typed one there. I don't want to grab all the attention of Kwame. I was curious if you're employing new technologies as well. And okay, so the technologies, I was thinking in drones for the coastal erosion indices, or perhaps low-cost instrumentation for these fishing sensors.
Yeah, so the use of drones, I mean, we have done that for details, to get details on some, especially on our CVI. So for wetland monitoring, I know we used a drone in Cote d'Ivoire and in Ghana. We had challenges moving drones from country to country. I mean, at the airport, my colleagues went through a lot in terms of getting the right papers to move these equipment along. So we haven't gone much into that, but it is doable. We have at some point also thought about using drones to estimate canoes, the number of canoes within landing sites. It's very simple. You put a drone with a high resolution camera, you fly it, and the approach is not so different from doing ship detection from radar. The canoe will sit in as an oval object, and you look out for these blobs, and you can estimate and count canoes from that. So currently, these are not operational stuff, but we've tried bits and pieces of the use of drones in fisheries management. Yeah.
Thank you. So Cooper, go ahead with your question.
Thank you. And this is more a comment than a question, but I just wanted to say, very well done, Kwame, and great to hear what you're up to and the other things. And, the book from the US perspective and everything like that, and being somebody who works between different parties and trying to do some of what you're doing, I think in many ways you're doing a better job, working from the fishing communities to the policymakers and in between. And so I just wanted to say, great job, and that's exciting.
Thank you, Cooper. Yes.
Thank you. So we have a question from Sophie in the chat box. And the question is, are you using new technologies like drones for coastal erosion?
That was me, sorry. It was earlier. It's already answered.
Yes, but let me, so I also have a colleague who actually even uses camera, right? A stationary camera that looks at a particular part of the coast. He takes data over time, and it allows him to look at the nearshore bathymetry. He's able to tease out shorelines, and so you can use, apart from drones, you can even use stationary camera to look at all of these things. There are expertise in Ghana. There are experts in Ghana who are able to do that. So the use of drones, camera, I mean, at some point, and it's something I'm even going to be working on with Cooper, is putting sensors on nets, right? I know we developed an IoT sensor that we put on a canoe, and it could take temperature measurements. I mean, I know in Pogo, it's one of the important technologies you want to develop among students and young researchers. So all of these techniques and technology exist, and it's something we can use to better look at our ocean space and better manage our resources.
Before we conclude, Subrato, I'm sorry, Kwame, would you have any training plan for the next few months that you could advertise here?
Yes, we can always do that. I mean, we'll be more than happy to send you some of our training activities that you can probably even nominate people to participate. It's fine with us. We can actually, I can also get my training officer to talk to you. Then we can have a collaboration between Pogo and do some of these trainings just for people within your network. Maybe once in 3 months or once in 4 months, we have a session on how to use EO data to look at ships, map oil spills, count canoes from like a low-flying drone and so forth. These are things we can work on.
Yeah, we're happy to share with the NANO members and public any training announcement you have.
Sure. Okay.
Thank you so much.
Welcome.
Thank you. So if there is no other questions, then I would like to close our webinar here today. So I'd like to thank you all for your participation, and thank you, Kwame, for your talk, very interesting talk. And we hope to see you all in our next webinar. Thank you very much.
Thank you for having me. See you some other time. Bye.